Good morning, class. Today we will be learning about the states of matter. So, as you should recall from elementary school, matter is anything that has mass and takes up space. Did you know that the earth is one large mixture of solids, liquids, and gases? So, one form of matter that you should be very familiar with is you. You're matter. You're taking up. You have mass and you're taking up space. You're all breathing in the air in my classroom and taking up space. I just mentioned that the earth is one large mixture of solids, liquids, and gases, but you should know that those aren't the only three types of matter. They're just the three that make up the earth. So, there are actually four states of matter. I'm not sure if you have ever heard of the fourth, but today you will. They are solid, liquid, gas, and plasma. Plasma just doesn't occur regularly on the earth. So the first is solid. I want you to think of some examples of solids that you see and experience every day. And when I say go, you can just start to shout those out. Ready? Go. Good job. So those should have included, if they didn't, some examples would be ice, shoes, TV, cars, pillows, even ice cream. Now you may be thinking, ice cream, that's a liquid. Well, it was a liquid before it became ice cream because, cream and milk are involved in the creation of ice cream. Those were liquids. But once it freezes, it becomes a solid. And it's also delicious. Next, we have liquid. What are some examples of liquids that you may see every day? Ready, go. Good job. Those could have included water, baby oil, honey, cooking oil, like olive oil, vegetable oil, canola oil, peanut oil, sesame oil, I said peanut, didn't I? And milk. All right. Next, we have gas. What are some examples of gases that you may experience every day? Go. Good job. Those could have included the bubbles in soda, which, if before you open it, you don't see those bubbles. But when you open it, they get excited and they just come out. And those little bubbles are just made of carbon dioxide that the soda company packs into your soda for, the carbonation. Next, you have helium in balloons, or the air from your body in balloons, oxygen and carbon dioxide. And oxygen is in the air and we breathe out carbon dioxide. These are all forms of gases. Now, you can't see them, but you definitely know they're there. Now, plasma. I'm going to give you a few seconds to think of plasmas. Some of you may be ahead of the ball and know. And for those of you that don't, that is fine, because I did not know what in the world plasma was when I was your age. Ready, go. All right. Now, some examples of plasmas would be lightning. Ooh, you didn't know that, did you? Stars, including the sun, and neon signs and fluorescent lights. Now, the neon signs and fluorescent lights in themselves are not the plasma. The glass tubes that make up the neon signs and fluorescent lights contain gases that react with the electricity when you plug them in, the neon signs and fluorescent lights, you plug them in. that interacts. The electricity and the gas particles interact, and they form plasma that glows, and that's how we have, open signs and such. And then, the fluorescent lights that we see in some buildings. So now I'm going to give you a few properties. Properties of solids. Solids can be hard like a rock, soft like a fur, big like an asteroid, or small like grains of sand. The key is that solids hold their shape and they don't fall like a liquid. So the only way you would see a rock flowing is if it was being melted by, a volcano, and if it, it would maybe turn into that states of matter transform, by melting, such as ice melts to water. But we're talking about them in their state as a solid. So a rock will always look like a rock unless something happens to it. And the same goes for a diamond. And we know diamonds are special. Solids can hold their shape because their molecules are tightly packed together. So if I gave you like your desk, that's not going to change unless someone comes in here and sets it on fire. So is baby powder a solid? Think about that for a second. It's powdery. When you put it in your hand, it kind of rubs in. Kind of. It's just white and really, really messy. So if it's not a solid, what could it be? Okay, halves. Yes, baby powder is a solid. It's just little tiny particles of talc that are just really, really tiny, kind of like grains of sand, but smaller. But it's still considered a solid. Next, we have liquids. Liquids fill the shape of any container they are in, like your water bottle. When you put water in it today, if you were at the water fountain, it would fill the bottom of the water bottle first. I'm sure you realize that because it all falls to the bottom. And then it fills the rest. And if you freeze that water bottle, the ice will still be in the shape of the cup or the bottle. The top of the liquid will usually be a flat surface. If you ever notice, even water, apple juice, soda, any of it, it'll be a flat surface. Soda will be a little different because of the bubbles, but it'll eventually, be a flat surface. And that's a result of the gravity that's pulling on the liquid molecules. It's actually pretty cool if you ask me. So, next we have gases. So the molecules in gases are really spread out. They're full of energy. And the molecules spread out and fill this whole space equally. So if you think about when you're blowing up a balloon, you put some helium in it, or you're blowing your air from your body into it. It doesn't just do half the balloon with air and other half is, just lump, flat. No, it fills the entire balloon. Gas molecules are just spreading out, and you're adding more gas molecules. So, like, even if you've ever made a balloon animal, when you see the guy or girl, it could obviously be a woman who makes balloon animals, you twist them, the gas molecules just move to another part and still spread out equally again. And every time you make a little, like the little hot dog, where you the different little parts, you make the tail has the same amount of air in it throughout, and the head as well, So the molecules are just spread equally throughout the entire shape. Now for some fun. We have plasmas. So plasmas are a lot like gases, but the atoms are just different. So, and as I said earlier, they aren't things that happen regularly on the earth. So if you have ever heard of the Northern Lights, they're actually pretty cool, and they're a type of plasma. The Northern Lights are basically just bright dancing lights that occur when particles from the sun's atmosphere collide with the Earth's atmosphere. So it's just gas particles colliding together, and that light that we see is formed from the plasma that is created, and they're really, really, really cool. You can see them from Alaska. You have to be in the northern, basically the northern hemisphere to see them, because they're called the Northern Lights. But you can also see them above the southern hemisphere. They occur above the magnetic poles of the northern and southern hemisphere. And it takes a very special environment to keep plasmas going. They are different and unique from other states of matter. Plasma is different from a gas because It is made up of groups of positively and negatively charged particles. And it's pretty stinking cool.